Good day everyone, my name is Lenarica Lovate and I am the last presenter of the group. So I will be presenting the different types of risk analysis techniques. So there are different methods to measure the standalone risk. So remember, the standalone risk is one of the risk analysis that is discussed in the previous presenter. So there are three types of the risk, which is the standalone risk, the corporate or the within firm risk, and the market or the better risk. So we have to discuss today the three methods of the risk analysis in standalone risk. So there are sensitivity analysis, the scenario analysis, and the Monte Carlo simulation. So the sensitivity analysis is a technique which allows the analysis of the changes in assumptions that is commonly used in forecast. So this is an example of the sensitivity analysis. So there are sensitivity analysis of the Shell Group, which has the $6 billion of cash flow and have a per annum of $10 per barrel. So in this price sensitivity, if the $10 per barrel will increase, so there will be an increase of cash flows. So while if there will be a decrease of $10 per barrel of the Shell Group, so there will be probably a decrease of cash flow. So that's how sensitivity analysis works. Next is the scenario analysis. So this is a risk analysis technique that is used which bad or good sets of financial circumstances are compared with most likely in the base case situation. So this illustrates different situations and choose of a better option of the variables. So the scenario analysis has the three cases, which is the best case, the base case, and the worst case. So in this example, so the 8,226 considered as the worst case because it has the lower NPV, while the 39,257 is the best case because it's accumulated highest NPV. So the base case here is the 15,567. So these values are represented in accordance to the project value of a certain company. So this is how the financial management or the analysis being described the different values that is presented in the sensitivity analysis of an industry. So the last method is the Monte Carlo simulation. This is a risk analysis technique that is used to predict the probable events that's simulated, and it is commonly used in a computer-generated estimated risk because it uses computer software. So this understand the impact of the risk and uncertainty in prediction. So basically it works in a software that uses numerous, which is enormous values of possible variables. Then it is more complex than scenario analysis, but this simulation makes the process manageable. So the Monte Carlo simulation, this is named after the Monte Carlo casino in the capital city of Monaco in Europe. So the Monte Carlo analysis or the simulation works. So first it runs simulation, so in the software, then it simulates random events, then plot distribution curve, which is presented in graphs, and this is how they make the decision based on the risk that they're willing to take to get the outcome if they want. So this is an example of the Monte Carlo simulation. So it comprises different kinds of numerous values, and it's represented by a graph. So the analysis also being predicted on the graph, so how they tend to grow and how it changes. So if there will be a mutually exclusive projects that have an equal lives and are repeatable, so the national or traditional NPV analysis may lead to incorrect results. So therefore, there will be usage of replacement chain or the equivalent annual annuity. So if there are different kinds of unequal lives that is being assessed in the industry, so this kind of analysis is used. And this analysis is commonly used in the corporate or written firm risk and also in market or the beta risk. So let us first discuss what is the unequal project life. So this is significantly different lives, which describes the different years or periodic timelines, which is years, months, days, just like that. And this is mutually exclusive and can be repeated. So this is an example of an equal life. So the machine A has 4 years, while the machine B has 2 years. So they have different lives, which is unequal lives. So the replacement chains, this is a method of comparing the projects with unequal lives that assumes that each project can be repeated as many times as necessary in order to derive a common life. So the NPV of the replacement chain is chosen, which the NPV has the highest. So let us give an example for this. So the company C is considering and investing into mutually exclusive projects which has the same initial cost of $10,000 at a different lifespan. So the cost of capital raised to finance the project is 15%. So as you can see in the table, so the project L has 6 lives while the project S has 3 lives. So the table also represented the different cash flow at the end of the relevant year. So in able to solve for this, we will be determining the net present value formula, which is the NPV is equal to net cash flow divided by 1 plus discount rate times to the power of the time of the cash flow. So the project L has the 6 lives. So we will be distributing the different the cash flow of the 6 years. So NPV is equals to 10,000 plus 2,500 over 1 plus 0.15, which is the interest to the degree of 1, then plus the 2,750 divided by 1, and so on and so forth. So we will be getting the $1,461.61. So in the project S, so it comprises 3 years. So therefore, we will be solving it in a common life, which is 6 years. So in the presentation, so the representation of the 3 different cash flows, which is the 5,250, then the 4,750, and 4,500. So the replacement chain modification to create a common life. So this cash flow is repeated in order to derive with 6 years. So the total NPV of the project S is 1,849.33. So in the replacement chain, so we will choose the highest NPV, which is the project S has the highest NPV. So therefore, the company C has to choose the project S since it has the highest NPV. Next is the equivalent annual annuities. So this is a method that calculates the annual payments that the project that will provide if it is annuity. When comparing project with unequal lives, the one with the higher equivalent annual annuity should be chosen. So the machine A has the 10% interest rate with a NPV of 4 million and with a lifespan of 6 years, while the machine B has the 10% interest rate, NPV of $3 million and 4 years. So as you can see in the example, they have the same interest rate, but they have the different NPV and have an unequal life. So in order to solve for EAA, so the EAA is equals to rate times NPV divided by 1 minus open parenthesis 1 plus R close parenthesis to the power of the negative n. So we will be substituting the values of the given. So the EAA of the machine 1 is equals to 10%, which is the interest, times $4,000 divided by 1 minus 1 plus 10% times to the degree of 6. Then it comprises to the total of $918,430. While the machine B has 10% times $3,000 divided by 1 minus 1 plus 10% of 4 years, negative 4. So it comprises of the total $946,412. So upon comparing the machine A and the machine B, so the machine B has the greatest or the highest NPV, which has highest EAA, which comprises of 946,412. So which is the machine B is better. So thank you for listening, and that will be all. Thank you.